Imagine you are packing fruit baskets for a school event. You have 12 apples and 18 oranges. Every basket must look exactly the same. No fruit should be left outside. So the question is, what is the largest number of identical baskets you can make? Let us test it. If we make 3 baskets, 12 apples can be shared as 4 apples in each basket, and 18 oranges can be shared as 6 oranges in each basket. That works. If we make 6 baskets, 12 apples become 2 apples in each basket, and 18 oranges become 3 oranges in each basket. That also works. Can we make more than 6 identical baskets? 7 will not divide 12 or 18 exactly. 8 will not. 9 divides 18, but not 12. So the largest possible number of identical baskets is 6. This is the need for HCF. When we want to divide things into the largest equal groups without leftovers, we use HCF. HCF means highest common factor. It is the largest number that divides 2 or more numbers exactly without leaving a remainder. Now, let us connect this with prime factorization. Suppose we want the HCF of 12 and 18. First, write both numbers using prime factors. 12 equals 2 times 2 times 3, so 12 equals 2 squared times 3. 18 equals 2 times 3 times 3, so 18 equals 2 times 3 squared. Now look only for prime factors common to both numbers. Both have 2, both have 3. But for HCF, we do not take everything. We take only what both numbers can share safely. For 2, the smallest power is 2 to the power 1. For 3, the smallest power is 3 to the power 1. So HCF equals 2 times 3, which is 6. HCF is for sharing, so take only common primes with the smallest powers. Let us try a larger example. Find the HCF of 96 and 404. First, factorize 96. 96 equals 2 times 48, then 2 times 2 times 24, then 2 times 2 times 2 times 12, then 2 times 2 times 2 times 2 times 6, and finally 2 times 2 times 2 times 2 times 2 times 3. So 96 equals 2 to the power 5 times 3. Now factorize 404. 404 equals 2 times 202, and 202 equals 2 times 101. So 404 equals 2 squared times 101. Now compare them. 96 has 2 to the power 5 and 3. 404 has 2 to the power 2 and 101. The only common prime factor is 2. The smallest power of 2 is 2 squared, so HCF is 2 squared, which is 4. HCF is about the greatest number that can divide, share, or measure both numbers exactly. Now, let us look at a different kind of problem. Imagine 2 lights on a wall. The red light flashes every 6 seconds, the green light flashes every 10 seconds. They flash together now. When will they flash together again? Let us list the red light times: 6, 12, 18, 24, 30. Now list the green light times: 10, 20, 30. The first common time is 30 seconds, so both lights flash together after 30 seconds. This is the need for LCM. When we want to find the first common meeting point of repeating cycles, we use LCM. LCM means lowest common multiple. It is the smallest positive number that is a multiple of 2 or more numbers. Now, let us solve the same idea using prime factorization. Find the LCM of 6 and 10. 6 equals 2 times 3. 10 equals 2 times 5. For LCM, we need enough prime factors to build both numbers, so we collect every prime factor involved, 2, 3, and 5. Multiply them. 2 times 3 times 5 equals 30, so the LCM is 30. LCM is for meeting cycles, so take all primes with the greatest powers. Now, find the LCM of 6 and 20. First, prime factorize both numbers. 6 equals 2 to the power 1 times 3 to the power 1. 20 equals 2 squared times 5 to the power 1. Now, list every prime factor that appears in any number. We have 2, 3, and 5. For each prime, choose the greatest power. For 2, we have 2 to the power 1 in 6 and 2 squared in 20, so choose 2 squared. For 3, we have 3 to the power 1. For 5, we have 5 to the power 1. Now, multiply them. LCM equals 2 squared times 3 times 5. That's 4 times 3 times 5, which is 60. Let us compare them with the same pair, 6 and 20. 6 equals 2 times 3. 20 equals 2 squared times 5. For HCF, take only the common prime, that is 2. The smallest power is 2 to the power 1, so HCF is 2. For LCM, take all primes involved, 2, 3, and 5. Choose the greatest powers, 2 squared, 3, and 5, so LCM is 60. One more useful check. If two numbers have no common prime factors, their HCF is 1. For example, 8 equals 2 cubed and 9 equals 3 squared. They share no prime factor, so HCF is 1. But their LCM uses all greatest powers, so LCM is 2 cubed times 3 squared, which is 72. Now, let us bring the lesson together. Today, you learned how prime factorization helps us find HCF and LCM without guessing. HCF is used when we want the largest exact division, like making identical baskets, measuring petrol, or choosing the largest square tile. For HCF, take the common prime factors with the smallest powers. LCM is used when we want the first common meeting point, like flashing lights, repeating bells, or step patterns. For LCM, take all prime factors involved with the greatest powers. HCF takes common primes with smallest powers. LCM takes all primes with greatest powers.